So far everything's been pretty straightforward. You add some functions, you subtract some functions, you multiply some functions, you divide some functions. But what if they are now something called composite functions? Let me just show you how to do this. I'll show you real easy. There's the h of x, okay? Now you're used to doing things like, oh, h of 2 means that wherever there was an x, you replace that with a 2, right? And then just bedmass it. 2 times 2 gives you 4. 4 plus 3, of course, gives you a lucky 7. But my question is this. What if this was no longer a 2? What if this was an x plus 2? What would you do? Well, yeah, wherever there was an x, you're going to replace it with an x plus 2. Well, what does that mean? Well, it means that you just get another function. That's all. Distribute, okay? There's going to be 2x plus, distribute again, 4 plus 3 gives you 2x plus 7. There's your composite function. You're composing a new function by taking two functions. That's what makes it composite. Okay? You're taking two functions and putting the two functions together. So what a composite function means is this function can be thought of as being composed of two functions. Take a look. This is that input-output machine thing. Do you remember from grade 10? Okay. Input-output machine says, okay, if I give you an f of x, and I said, okay, your input is multiplied by 2. So whatever you put in as an input for x, you multiply it by 2. Then you're going to take that result and you're going to add it to 3. Boom, boom. That's it. That's all you're doing. Okay? So think about it. You're taking this, right? And you're basically putting it in here. Right? Think about it. Multiply by 2. Whatever you get goes in here. Add 3 to it. So basically, if you think about it, this 2x is going to replace the x by saying 2x plus 3. There's your new composite function. There's your new h of x. So in this particular section, all you're doing is you're putting functions together. Okay? So when you substitute f of x into g of x, think about it. G of x, g of now, was some sort of blank plus 3. What are you substituting in? You're substituting f of x into there. What was f of x? F of x was 2x. 2x plus 3. Huh. Deja vu. I already did that. I did it simpler. Okay? But that's basically what you're doing. You're taking a function and you substitute it into another function. So here's all the definitions from the textbook. I love this. What is the composition of functions? The composition of functions, f of x and g of x, there it is. You're substituting a g of x into an f of x, or an f of x into a g of x. It all depends on how they write this beautiful thing. Okay? Now, most importantly, what about the domains? F of x and g of x exists only for the domain to which both of them are defined. F of x and g of x are defined. And then, how do you read it? Real simple. F of x, or f of g of x, sorry, f of g of x. When you see this of, look what we did. We put a small little circle. This reads f of g of x. Done. So two different ways of writing it. You can write it like this, f of g of x, or you can say, oh, I'm just going to put my g of x inside of my f of x, and then I'm going to figure it out. Now, you're probably looking at this and going, this is really confusing. Trust me, upcoming podcast, I'll sort it all out for you.